All right, number 5, we have, looks like a total of 11 parts here. This time we're given the equation in standard form, and we want to find several things to do with this equation. So we have f of x equals 2x squared minus 3x plus 5. Now, when you see standard form, you want to compare it to just the generic, which is ax squared plus bx plus c. This is what you're wanting to compare this to. This is just the generic with the letters and variables plugged in. When we want to find the vertex, the book gives us a different formula. So the x-coordinate, or the h that we're used to dealing with, when we have it in vertex form, is equal to negative b divided by 2a. All right, and then the k, or the y value here, is going to be 4ac minus b squared divided by 4a. Okay, so we're going to use this formula to find our vertex. All right, so you got to be able to identify b, c, and a. They're in, a is in front of x squared, b is in front of the single variable x, c is the constant. So let me identify that. A equals 2, b equals negative 3, and c equals 5. All right, so we're going to evaluate and find both these. When I plug in a negative 3 to a negative b, it becomes positive. So I have a 3 over 2 times a, and a is 2. So this ordered pair gives me 3 over 4. So of my vertex, my x-coordinate is 3 over 4. All right, and now I got to find the y-coordinate. So for that one, I have to do 4 times a, which is 2, times c, which is 5, minus b squared. B is negative 3, square it, divided by 4 times a, and a is 2. Okay, so if we simplify this, 20, 40 minus 9 on the top. 4 times 2 gives me 8. Give us 31 over 8. So that is our y-coordinate, or our k. 31 over 8. So that would be the best way to do your vertex when you have it in standard form. Okay, use the formula here. This is your vertex. This is your HK. A lot of these parts should remind you of the quadratic formula. Negative b, you got the plus and minus. Square root of b squared, 4ac is just reversed, and then all over 2a. So all of that part is similar to the quadratic formula. So in this case, we have 3/4 and 31 divided by 8. All right, once you have your vertex, we want to find the equation of the axis of symmetry. And remember, again, just like the previous, that is the same as your x value from your vertex. So it is just x equals 3 divided by 4. That's a give me once you have your vertex. Concave up or down. Okay, if I look at this equation, the a, the number out front, 2, is positive. So it will be concave up. We'll be going up. All right, the x-intercepts are. So in order to figure out the x-intercepts, we want to do quadratic formula. X equals negative b plus or minus square root of b squared minus 4 times a times c, all divided by 2a. Now, before we actually compute the whole thing, we can determine if we actually have zeros by focusing on the part underneath the radical, the b squared minus 4ac, which is called the discriminant. And let me just pull it up from the text. I'll show you there. Textbook, save me a little bit of writing here. Okay, and let me go over a few pages. Let's say 308, I think. Should get us pretty close, yes. Okay, so this is a summary, the very end of the section. And it says find y-intercept, you plug in a 0 for x, and then x-intercepts. So we're looking at that discriminant part we just talked about. That's the part under the square root. If it is positive, so that's what this means, greater than 0 or positive, then you will have 2 x-intercepts. Okay. If you do that part and it equals 0, you will have 1 x-intercept, or the vertex is the x-intercept. And if you do the discriminant part and it is less than 0 or negative, there will be no x-intercepts. So we're going to find out how many we have, and that's going to be part of what we need to do to solve it. And then we'll actually go ahead and solve it. So let's just do this part first, the b squared minus 4ac. And either it will be greater than 0, which means we have 2. It will be equal to 0, which means we have 1. Or it will be less than 0, negative, and we have none. All right, so up above, we have our a, b, and c. So if I was to do, just extract this part, b squared would be negative 3 squared minus 4 times a, which is 2, times c, which is 5. So just focus on this part. This gives me 9 minus 40, and 9 minus 40 gives us a negative 31. Negative 31 will fall into this scenario. Less than 0 is negative. We have no x-intercepts. We will have none in this case. We don't even have to finish the whole quadratic equation. There are none. All right, y-intercepts, very easy. When it's in standard form, you just plug in zeros for your x values. And what I like to do when I have the equation written down, I just cover them up, because when you plug a 0 here, the whole thing goes to 0. 0 here, whole thing goes to 0. We're just left with the 5. So our y-intercept in this case, or f of 0, is equal to 5, because everything else will cancel out. So it doesn't ask us to type it as an ordered pair, so we just put 5. All right, so now we want to know which one is the correct graph. One thing I do know, it crosses the y-intercept at 5, it opens upward. So looking at these options, B opens up and D opens up. Which one has a y-intercept of 5? D, 1, 2, 3, 4. D crosses at 5. What about B? No, it doesn't. So D is our graph. More than welcome to plug it into the calculator and graph it. The domain. So if you refer or recall when we did domain, this function does not have any fractions, square roots, or logarithms. So domain is going to be all real numbers. When we do our range, okay, we're going from lowest point to highest point. So since D was our graph, the lowest our graph comes down, okay, is this vertex point, the lowest point, x, y. We're in the y direction now when we're doing range. The lowest point on the graph is 31/8, and that would be here. So if I was to kind of just do a little rough sketch, this y value at the bottom is 31/8, and then the graph goes up to infinity. So we actually do reach 31/8. So 31/8 is going to be my low point, and infinity is going to be my high point. So that would be our range for our graph. And it all depends on if your graph is opening up or down. If your graph was opening downward, your low point would be negative infinity, and then it would come up to your, whatever your high point is, again, your vertex. So if this was the case and it was just flipped around, if this was 31/8, then we would come up to 31/8. Okay, but this is not the case. This is our case here, so we want this to be our range. 31/8 in a bracket. Going all the way to positive infinity. All right, so E wants to know where the quadratic function is increasing and where it is decreasing. So we read our graph going left to right, just like I would read a statement. I start on the left and I read right. A graph is read the same way. We are focusing on the x-axis. Okay, so let me do this again. So our parabola, or our graph, let me just pull up the picture that we had. So here's our picture. And I'll just kind of extract that best I can. Let's say that this is 5. Something like this. It's close enough. This vertex point is, what was that? 3/4 and 31/78. 3/4, 31/78. Okay, I'm gonna label that. This is 3/4, 31/8. Why did I say 78? 31/8. This is the x value right here. X value. 3/4. All right. The way we determine increasing, decreasing. Again, read left to right. The left side in the x direction is negative infinity. So because we have an arrowhead, that means this graph is coming all the way from the left from negative infinity, and it's going downward, which means it's decreasing all the way starting from negative infinity, and that's just saying on the left side of the graph, not that it's coming from the bottom, but we read left to right. So it's decreasing from the left side of the graph, from the negative side, until we get to the number 3/4. So we're describing it based on the x-axis. So the left side of the graph, from negative infinity to 3/4, is decreasing, going downward. Then the graph starts to increase, going left to right. It starts going up when we get past 3/4. So increasing from 3/4 to the right side, which is going all the way to infinity, positive infinity. So this is how we describe increasing, decreasing based on the x-axis, where it starts and where it stops. So the first is increasing. That is 3/4 to infinity. And then decreasing, that was negative infinity on the left side until we got to 3/4. All right, so the last part, we want to know where the y value, remember f of x stands for y, where's the y value above 0, so that is the x-axis, this 0 line, and you can see the whole graph is above. And then we also want to know where the y value is below 0, so this line 0, what part of the graph is below. And again, we describe it based on the x-axis. So it starts above the y, the x-axis at negative infinity, and it stays above all the way to positive infinity, the whole graph. and nothing is down here. So we're going to pick that. So B says never negative, so that's the one we want. And the part that describes where it is positive, we would say negative infinity to positive infinity. So the whole graph is positive above the 0 line and nothing is below.